Hello everyone, and welcome to Rebelway. My name is Andrew Sutherland, and today we're going to be creating this fire scene. So this final scene that we're going to be taking a look at was a combination of the Rebelway effects team and one of our students. I think the student Ayash Ramana originally created some sort of fire setup, and Saber saw the potential it had, so he did some tweaks on it, then did some renders and some compositing. So this is the final result that we see here is a combination of their efforts. And we're going to take a look at how that was done. But before we jump into the overall project, as always, I'm going to do my best to get everyone on the same page and build a little setup from scratch on creating, some pyro simulations, preparing fields for our simulation, and some masking techniques. So let's jump into Houdini, and first thing we're going to want to do is put down a sphere. So we now have some geometry here, and you can see that this is positioned at, zero, the origin of our scene, so 0. And if we take a look, we've got 1 here, -1, -2, and this is our X, Y, and Z. So the Y is our up, the X is along, and the Z is like this. So just to make things easier, I'm going to make the sphere give it 1 meter in this direction, 1 meter in this direction, so the overall size of this sphere is 2 meters, and that's just going to make it a little bit easier for me to explain what's going on. And what we need to do is we need to convert this into a density volume. So for that, we're going to put down a VDB from polygons. And this is going to create a assigned distance field. So this is our surface field. What we need is not surface, but density. So now we can see we've got some, before it was just like the shell of the sphere was created into density, and we want the entire thing to be filled with smoke or density. And we're going to tick on full interior just to make sure. And it's quite low, so we're battling to see it. And if we press D on our keyboard, we can change this to dark. But what I want to do is I want to actually increase the value of this density. So I'm going to put down a volume wrangle. And I'm just going to simply multiply the density. So we're going to say at density times equal 10, and you can see now we've got a lot more density. So basically each voxel has a value, and that value is now 10. Before that, the value was the density was 1, and now we have a value of 10. And so we're now going to take a look at how to manipulate and create some mass for this density. So what we're going to do is we're going to put down a volume wrangle. Sorry, a volume VOP. And we're going to dive inside. So the first thing I want to do is I want to take the position of each one of these voxels and use the position data to map that value onto the density. So like you just saw before, we had a value of 1, and then I multiplied it up by 10. And what I actually want to do is take the position data. So here, the position of these voxels are 0. Here, they're at position 1, and here -1. So if we take that position data and remap it to the value of the density, well, then we're going to have values of 0 here, -1 here, and 1 there. So let's take a vector to float, because position is a vector. So we have vectors which are made up of three attributes, and floats which are just 1. So the X is a float, the Y is a float, and the Z is a float. But all together, the position, because the position is the where it is in X, Y, and Z. Well, that position is a vector. So we can take the position And we're just going to use the X, and we're going to export that as density. And as you would imagine, you can now see that this is the value of 1, and then it's gradually going down to 0, and we can't view negative values in density. So, you know, there's information here, but we can't view it. So this is our result. And what we actually want to do is we want to remap these values to 0 to 1. So for that, we're going to put down a fit range. And we can map this to -1 and 1. And now we have, this will be 0 and this will be 1. So that's what this fit range is doing. We're fitting those ranges between -1 and so -1 value is going to now become 0 and 1 is going to remain 1. And that's what this fit range is doing. And fitting values like this is often also referred to as normalizing. Normalizing means that we have values between 0 and 1. And in Houdini, a lot of the time we want to normalize our attributes just so that it's easier to control. So next we want some more control over our density. So I'm going to put down a ramp. We're going to change this to spline. B-spline. I think we need to come out here. Sorry, ramp type, and we change it to spline. We jump back out here and we need to raise this. And now we have exactly what we had before. Yeah. But now we have this ramp that we can manipulate, and we have more control over our density. So if I wanted to isolate just the very middle part, yeah, we could do something like that. If we wanted just the second half, or yeah, you get the idea. We have now control over this density. And so actually what we're going to do is we're going to create some high values here and nothing here. So there's no data on this side, but we do have on this side. Let's increase this. So now we've just got half and half. Cool. And this mask is quite useful in Houdini because we could create a whole bunch of different masks like this, and we could multiply any other field by this mask. So like for instance, if we wanted to you know, kill all the velocity or temperature in this side, we could create use this as a mask, multiply it by this mask, and then all of a sudden we're not going to have any data on this side, but we will here. And like I showed before, you can manipulate this mask to control where you want specific data. So next up is I want to put down a name node, because currently, if we take a look at this, this is density. And what I want to do is I want to rename this to temperature. So I'm going to put down a name node. And I'm going to select the density, and I want to rename this to temperature. And as you can see, it is now temperature. Let's maybe give us a bit more resolution. So decreasing this voxel scale means that we're going to have more voxels, meaning higher resolution. And what we can do is we can just merge this field with our original field. And now we have density and temperature. And you can see, we've got both of them overlapping here a bit. So let's just put down a visibility, and that's going to hide our temperature. So it's there, but we just can't see it in the viewport with this visibility node. Cool. Next up is we can put down a DOP network. We're going to put this into our first context geometry, and we're going to dive inside. So this is an empty DOP network. So we need a pyrosolver. We use the sparse one. We need smoke objects. Use the sparse one, and that goes into our first thing. And a volume source. And I'm just gonna, it comes, you know, default like this, source smoke, but it's not set up correctly. So we just click off and then click back on just source smoke. And now it's, you know, it's importing density, temperature, and velocity. We don't have any velocity yet, but we can just leave it as is. All we need is density and temperature. I always like to tick on enlarge fields to contain sources. And we're reading in our first context geometry. That just means that first input here. So cool, we have that data coming in. So if we click play, we have a simulation. And as you can see, it is shooting up where we've got temperature, and the density, that's just density. We're not getting any of this advection here. So let's jump. Yeah, let's jump. Well, let's wait. First, let's put down a ground. We can just enable a ground with this node now. So we treat Y as close below. And you can see now. Yeah, that's cutting off. I think that should act as a ground nicely. Let's see what else. Let's put down a gravity. Yeah, so you can see this is working as a ground, and our density is colliding with that ground, and it is moving out here. So let's display this nicely. I'm going to put down a DOP IO. And we need to read in our DOP network, and we need to read in our smoke object. So I always forget which one this is, but I think it's this one. We need to change this to smoke, and we're just going to import, let's import the velocity and the temperature. So now we're importing just density, velocity, and temperature. As I said, I always mess this up. Yeah. Cool. Let's optimize our fields that we're importing. So let's put down a pyro post process. And we can convert that to VDB, convert that to 16-bit, save us some disk space, and we can resample the velocity with a scale 2. I think that's fine. Yeah, so we're importing our density, our temperature, and our velocity. If we untick this resample vel, you can see this data is a lot larger. So you can see it's 112 by 2, and we can resample that. And now we save some disk space. Cool. Next, let's put down a volume visualizer. Let's use the Pyrobake. Pyrobake. And we're going to enable the fire. And the fire is now visualizing the temperature with this color ramp here. So let's see what we got. Cool. So the next thing that we want to do is we want to give this some more detail. So let's dive back into our DOP network. And actually I like visualizing it with our color. So what we can do is we can pin this to the viewport. And that just means that when we dive into DOPS, we're still visualizing it with this Pyrobake node. So let's dive back inside and let's put down some turbulence. And I'm going to change this to the sourcing, and I'm going to put our microsolvers into here. And I'm going to change the scale to 4. And let's give that a go. So as you can see, we're now breaking up this volume quite a bit. That's pretty cool. So how can we control this a little bit more? Well, under binding, we can see that we are disturbing the density, and we have density all over our sphere. So basically this gas turbulence is affecting the entire sim. And what we can do is we can change this to temperature. And now you can see that we're no longer disturbing this density area, but we are disturbing where there's temperature. And under control settings, what we can do is we can enable this control field. And this acts like a multiplier. So like I was showing where, in this VOP, where we create this ramp and we just isolated, let's take a look at it. We just isolated this side of the density, right? Well, now in this microsolver here, it's the same thing, except we're using this as a multiplier for our temperature. So we can enable this. So we can enable this, and this can be a little bit confusing, but once you wrap your head around it, it's pretty obvious. You just need to sit and think about it. So this is our lower density. So wherever there's low density, it's a value of 0, and wherever there's high density, we're gonna have a value of 1. And if we're multiplying that by our temperature, only the very high dense parts of our temperature is going to get disturbed, and our low parts of the temperature will not. So let's take a look at that now. Let's come back out here. Let's let this run a bit. Yeah, and as you can see, where it's dense here is getting very disturbed, and as it becomes less dense up here, we're getting less turbulence. And we can of course reverse that. So let's flip it. And now we should get turbulence in the very low dense areas. and none in the high dense areas. So let's just check that. And it's a bit hard to see, and I know why. And it's because this control influence is only affecting it by 50%. We don't want that. We want it to be 100%. So this should be a bit more clear. Sorry about that. Yeah, you're starting to see it a bit better there. Let's flip it. Give ourselves some more. Now, our low dense parts won't get any turbulence, but the high dense parts is getting turbulence. Cool, so I hope that explains the control fields and the bindings for our microsolvers. So I've created some flip books here so we can take a look at these microsolvers and what exactly they do and how they affect our simulation. So at the top, this is our default simulation. And as you can see, there's no microsolvers being applied to the simulation. The detail that we get in the simulation is purely coming from our source emitter. So the breakup is giving a bit of detail here. And as you can see, we have the temperature, and on this side of our sphere, like I showed, we're not seeing any buoyancy. But if we apply this in this case, we've got disturbance. We can see how it's creating this puffy smoke effect, and that is the result of disturbance. And you can see that this is happening on a voxel scale here. And it's just moving those voxels around, and that's what we call disturbance. And if we take a look here, we can take a look at turbulence, and this is how it's being visualized inside the sim. We've got these vectors that are sort of moving the smoke around almost like a wind, but you know, it's in this sort of in the swirly curl noise type of motion. And that's what we see as turbulence. And here, shred, similar to what we see in the turbulence, but this is creating some breakups in our simulation. So these are, I wanted to make these flipbooks just so we can compare disturbance, turbulence, and shred. And disturbance and turbulence are the two that are my favorites. I use these all the time, but of course there's loads of microsolvers in Houdini. So if you have some time, like, experiment with those microsolvers, create a setup like this, run some tests, and look at reference and see what are the similarities in the reference and to the result that you get from the microsolver. And that way, when you're creating an effect, you can look at some reference and say, oh, I can see that there's this sort of puffy look. Well, then you know you need some disturbance, and then turn up your settings based on your reference. So eventually, with a bit of practice, you can start getting closer to matching references. What I like to do often is just run tests like this, use just turbulence, use just disturbance, and that way you get an idea of what that microsolver is doing in isolation. And if you look at some reference, hopefully you'll be able to pull that apart and know what to use and when to use it and how much. When it comes to also talking about how much, as you can see here, this is turbulence and this is turbulence, and I've just printed my settings, well, some of the settings onto the screen so I can compare. This is a value of 10 and this is a value of 4. So also run tests like this, just it'll help your eye determine, you know, what sort of values to put in. And at the end of the day, when you're matching reference, you do need to run multiple simulations and compare and know, which set, if you're going in the right direction or not. Same thing I did with the shred. You can see this has got quite a high value of 5 and this is 0.5. So that's the difference that you're getting between the two. And the disturbance, I liked this default setting, so I just kept it as that. So we're back in Houdini now, and I'm just going to show you how I created the setup and printed this my settings to a screen. So all I did is I put down a camera, and then I put down a font node, and what the font node allows you to do is just write some text here and it'll come up. So you could just write test, and if I switch this to my first switch, we should now just see test. And we can also copy paste parameters and put it into this H script. So for instance, before I explain that, I should just say I pinned this font node to my camera and ticked on keep position when parenting. So you put down a camera and you just link this, and now this text will move around with your camera. And as for getting the settings, I just went into Houdini and I put down a switch here once again, and I plugged in all my microsolvers, and I linked the switch to the one in the font node. So just by copying parameter, come over to the font node and I paste relative reference, and now these switches are going to change. And that way I can just look at my simulation without any microsolvers. Then I can take a look at it with the turbulence, the disturbance, and the shredding. And at the same time, I can print the relevant information to my screen. So let's try something like that. So this gas turbulence, I can just say copy parameter, jump into the font node, and I like to paste it into a blank font node first, paste relative reference, and then I just copy it from here using my keyboard. And this is scale, you can see it says there, so I can write scale and paste that link there. So that's how that setup was done. And then for the visualization on the microsolvers, you can just come over to here and enable visualize. It seems to be working now with the switch, which is strange because as you can see now it doesn't. So a lot of the time I actually have to just plug this directly in and it shows up. So I just did that for each microsolver. As you can see, if we were to increase the turbulence, now we've got something more like that, and just run wedges and compare them, because it's quite difficult to just look at one result and be confident about what you're seeing. It's only when you compare them side to side that does do a lot of these things make absolute sense. So as you can see, the swirl size seems to be getting smaller here. As you can see now, this just means it's less strong. So sometimes you want a high value, maybe not for your final simulation, but when doing tests, I'd like to make it quite high and then get a good idea of what the effect is doing, and then obviously tame those settings down for your final simulation, or create specific masks and fine-tune your final look. So hopefully this helps you guys. I'll include this in the final file so you can take a look at it, add more settings to your visualization, run more tests. Like I said, there are loads of microsolvers in Houdini, so you can go through all of these and run tests if you like, but my two favorites I would have to say is gas turbulence, gas disturbance. Another one I like is gas vortex confinement. Gas vortex confinement. And this basically emphasizes or exaggerates the swirls and details that you have going on in your simulation. So I always add this into my simulations just to kick the detail up a bit more. Okay, so I've got the file open that was created by one of the Rebelway students. And as you can see, we've got some pre-roll here. And then when the camera starts moving along with our character and shaking a bit, that's the scene that we're going to render. So let's take a look at how this was put together. And everything simulation related is going to be inside this geometry SOP here. So if we dive inside, first things first, we can see that we've got this environment. And if we come over here, we're importing this truck. Now this truck is pretty big. So we're going to scale it down. Let's look through our render camera again. We're going to remove the windows. So this is just, yeah, you can see we've deleted those windows there. We're going to set the normals, compute normals, and we're going to do some cleanup on our geometry. So before, we had a whole bunch of attributes, and we're pretty much deleting all our attributes, and we're just keeping the normals, which we set here. Then what we do is we've got a group, and we're isolating the edges by enabling this enable, and we can select our edges like this and apply a remesh. So it appears that this remesh is not reading in any group, it's just applied to the whole truck, something like that. And then we have a transform just to place the truck in position for our scene. These are our settings. And then we have this attribute paint. And if we come over to this button over here, we can see that this has just been painted in manually. So you can just come over here and add if you want. You could also maybe try recreating this with the noise. And I'll show that a little bit further down. And here we're creating a new attribute called new normal based on our current normals. So if we take a look here, we can see we have mask, normal, new normal, and P. So we've created this new attribute based on these pre-existing normals. So it's like a copy of that attribute with a new name. And then what we're doing is we're removing the geometry based on the direction. So using a delete SOP, we're deleting from this angle, and that's basically going to delete a lot of the geometry from behind the camera. Next we have this labs delete small parts, and that's going to delete those, based on its size. If you bring this up, it starts deleting parts based on its size. And then this is a clip, which is going to remove this bottom part. So now we're just left with this part of the truck. And then this is the way that the file was set up, using the scatter, so scattering points on the surface, and then using this blast node. It just looks like points were manually deleted. And I thought I would just show slightly more procedural way of doing something similar. Like I said, this is the final result that you see in the render, so I'm keeping it. But if of course you wanted to, you could use an attribute noise, and you could change it to color. So before, we're just putting down some color, and then scatter points based on that color. Oh, I should make sure this is changed to 0 censored. And then I put down a color just to remove this red. And you can see now that we've got some sort of breakup on these points. And then if you actually wanted to reduce the amount of points, I just said, so these points all have an ID number. And so I'm saying if the point number randomly is less than this threshold that you set here. So if you type this CH and threshold and then you come over and click here, it's going to create this slider here. So basically all we're doing is we're deleting a percentage of our points. So, you know, now I'm deleting 100, I'm, you know, deleting 100%, keeping 0%. This is 50%, and you can see our point numbers changing as we slide this up. So this is just a cool way of optimizing the number of points. Of course, you could also just reduce the amount of points here. You know, essentially do the same thing. But if you want some extra control, you know, after you've got your setup working, I like to use this vex expression. Then once again, we're now doing the opposite of what we had. So we keeping these sides, putting down a labs, delete small parts again, and we're scattering on the top here, moving it just a little bit up. And same with this one, we're moving this one just a little bit outwards, so like that. And then we're merging that together. So we have something like this. We're going to put down a null and call that out points, and we're going to put those into an attribute VOP. But in order for this to make sense, we need to come down to this copy to points, and we can take a look at what's happening here. So we've got a line. It's just a line in the Z direction, and we're using this UV texture to create some UVs on this line. And then what we're doing is we're taking the red component of the UV texture, and we're putting that into an attribute called U. So we now have an attribute called U, and that is based on the red component of our UV texture. And then we're going to put down this copy to points, and as you can see, we now have this line copied and transformed to all the points. So let's come back up to this attribute noise, and you can see we've promoted a few parameters here that will define the look of this fire. So we've got a length, and yeah, that just obviously controls the length. We've got a frequency for our noise. We've got some offset, which is going to apply some animation. We have an amplitude of 1, and we have roughness, and again, offset and offset. And those offsets are coming from a noise. So if we dive inside, you can see that we're taking the position, and these are the controls that have been promoted to the object level. And we're just fitting that. So we've got values between 0 and 1. And we're adding that to the normals. And this power is, I kind of think of this like contrast. So if I were to turn this off, you'd see it's not too different, but it's sort of exaggerating the length here. And so that's going into a length, and then we've got this global multiplier for the length that we see here. We're fitting that, and we're exporting that as p-scale. So this is going to basically give us the variation on our length. And this noise is also going out to the normals to give us the direction. And we have these two other noises. Clamp, a multiplier, a fit, and we're adding that to the p-scale. You can see that that is being added there. And the controls, like I said, are all here. Here we have a point VOP. Again, we're promoting the offset. A turbulent noise, another turbulent noise, another turbulent noise, Here we're taking the upward position and we're multiplying that by the P scale. And we're exporting that as P scale again. And if we deactivate this, you can see that we're now varying the size drastically by that noise. And we're using this wrangle here to reduce the direction. So we're maintaining the direction of the upward, and here we're killing this direction. So let's add this one back. You can see we've you know, these lines are kind of going towards this direction, but we don't want that, so we're just going to make that 0. And this is also being reduced, you know, by like 25%. So without it, we want that organic sort of looking thing, but we want some more sort of upward directions like that. So those are the settings. Just to go over this again, let's disable these so we can take a look at this. This one is setting the overall noise like that, so we've got some variation. This one is going to like sort of contrast that a bit. And then this one, we're reducing the directions. So that's that. This one, here, we're just keeping this one as is. We're creating a UV for all over. And here we're we're creating an attribute called C, and that's based on the red component of the UV texture. So we just got like a black and white gradient. From there, we're sort of blending the two. So we got that and we got that. Let's see if we're sort of blending the two here. So we're taking the overall UV texture. We have this mask that it comes from up here. From this attribute paint. So we've got that mask. Reading that in. And we're using that as a multiplier for all of this section. So I mean, let's maybe, you know, without the mask and with the mask, we're sort of masking that out. And we're using this UV texture to create an overall ramp. And then we're mixing the two. So we've got a little bit of this, we've got a little bit of that. We're multiplying it by the UV texture, and we're also multiplying it by that mask. And so these are our current curves. We're going to add some more noise to them. And we've got some animation on the Y. So we now have something like this. We're putting down a polyframe so we can compute the tangent, and that's being called tan. We're measuring the length. We're promoting that length parameter from primitive to points. So we're reading in this parameter attribute, and it's being mapped from black to white. So the very long ones are white, and the short ones are black. Or at least gray, and we're clamping the white, so we get more white than we would normally. So if we turn this up, so we clamping that a bit. So next up, we're putting some velocity on our points with this point velocity, and we can come over to this display point trails to see our velocity, and you can see we've got some cool noise on our points. So something like that. Here we're just using this clip to remove anything below the ground. And then we're sending it to this pyro source node, which is going to create this burn attribute. We're setting in the p scale here and the particle size, but essentially it's creating an attribute on all of these points called burn. So from here, we're putting down another attribute noise, and we're messing with the velocities. We're using the upward component, and these are our settings. So we're just manipulating the velocity a bit there. So not a huge difference, but we are just making this feel a little bit more organic. And then we're using another noise. So next up, we're adding another attribute noise, and we're distorting the burn a bit. Let's put down a color node so we can see this a bit better. So we put down a color, and we come to attribute from map, and we type in burn. You can see now we have this breakup, so before and after. So that's what we're doing there, and we're manipulating the burn once again. So let's take a look. So just a little bit more dark areas. And then we've got this name node, and we're calling it source name, and it's based on the burn and the velocity. And if we come down to this volume rasterize here, you can see that we've got that source name in here. So without that, we've got this, we've got attributes, we've got fields, you know, everywhere. But with this on, it's a bit more masked out. So that is coming from this source name. Then here we're fitting this burn, and we're also multiplying it up, and this is going to give us some more contrast. So it's going to kill these areas here, as you can see, like that. And then we're just going to save this to disk. So using this volume visualization node, we can, you know, view the temperature and the emission, and we have this. This is going to be our source for the fire. And the three fields we have is burn, temperature, and velocity. Next up, we've got our DOP network, and here we're reading in the truck, and that's going to be our collision. So that's going to go into the second input. And this first input is going to go into this first context geometry. So let's dive inside. And we have our smoke object, we have our pyro solver, we have a ground, and we have, this is our first input, and this is our second input. And you can see here the collision is set to -1. And it's got some collision val, and that just means that this is now going to collide with our simulation when you put a value of -1 here like that and set to collision. And this one is set to source fuel, so we've got our temperature coming in, and that's going to be remapped to density with a value of 0.1. The burn is going to go into the flame of 0.8. And the temperature into the temperature at 0.15. Well, not point at 1.5, and the velocity into the val at 0.5. So this is the values for our source. These are the values for our collider, and then we run the simulation. So let's take a look here. We're calculating a speed field. These are our settings: the temperature, the buoyancy. Gravity, we have gravity on here. We just got a bit of dissipation here. So these are micro solvers, and you can see in this setup, instead of using the turbulence and wind and all that stuff here, we actually got a designated micro solver for each. So this one is going to do some shredding. This one is doing some gas turbulence. Another gas turbulence. Let's see. Pretty straightforward. Another gas turbulence. This time we've got some control on the flame. These are our settings. Some wind. Some gas vortex confinement, which just exaggerates all our settings. And a gas disturbance. Cool. So that's it for our DOP network. And we then put down a DOP IO and we set this to, you can say, smoke, but all we really interested is the velocity. So I can kill this velocity, the temperature, and the flame. And we reading in this network here, and it's masked by this smoke object here. That just means that, you know, we're going to only import the simulation. So if there's a flaw or anything like that, we're not importing that. It's masked by just the smoke object. From there, we've got a post-process node, and we're computing the min and max. We're converting it to VDB. We're converting the volumes, and we're converting to 16-bit float. And we're also resampling the velocity. So what this does basically is it's just making it half the size of the original cache for the velocity. So if we were to take a look at this cache now, it's not showing up in the viewport because we need to visualize it. But if we took a look at the size of it, you can see that our flame and our temperature are around about the same size. You know, about mid-res, but our velocity, since it's something that we're not going to render, we don't need to view that detail. So we can reduce the velocity by this resampling the volume by 2, and that's just going to save us some disk space. So that's that for our simulation. We've got a null here. We're just going to visualize this with, and we're not using this, so let's plug this in here. This is what our simulation looks like currently, and what we're going to do is we're going to put down a blast, and we're going to delete everything but the temperature, and we're going to rename this temperature from temperature to density. So if we take a look at this now, we've got this as density, and then we're going to merge this with the original. So we have temperature, flame, velocity, and density, and now we can put down this pyrobake node, and we have this as our final fire. So before renaming and combining things and post-processing it with this pyrobake, we had something like this. And now we have that. So that's looking pretty good. And let's just take a look at this pyrobake node. So on the smoke, we've got some brown temperature, some brown color. On the scatter, these are our settings. And we're visualizing the fire. And that's it. Cool. So that's that for our fire. That's our fire simulation done. Next up, we're going to create the smoke. So we're going to start with a circle. And this is basically, we're just noising up the position a bit and, you know, doing that again, merging these two together, transforming it into place. And this Boolean, this is going to, you know, clear up a few of those issues there. Not that it matters because we're going to scatter points on it. And in this case, we're going to divide it. So fine. Okay, we're going to connect in. So we just got an outline. Yeah, so the Boolean does help with this. We're going to delete those inside pieces. We're going to scatter along the edges. We're going to color that. We're going to scatter on the middle. A point VOP like we had done before, just creating some curl noise, and we've got a power for the contrast, we're computing the length, and then we're exporting that as the P scale, and then this is exposed for our basic, so for an extra level of control, and then exporting that as normals. So like we done before, you know, we have to come down to the copy to see exactly what that does. But you can see we now have got these lines that is going to control our fire. So it's just like before, we had a line, we've got the UV texture, we've got this wrangle so that we can create this U attribute based on the UVs. And we're just basically using that to manipulate the line and give us these pretty much exactly like we did before. It's just you can see a different use case for it. So yeah, this is just being used to control the P scale, which is going to control the length of this line. And then of course we've got the copy to points. We've got some more noise, some flow noise. And that's just basically giving a more organic look by shifting the position. And a pyro source, this time just density. So we've got density. We're randomizing the P scale and remapping it a bit. More manipulation of the P scale. And then we're noising up the density. So let's put down a color so we can visualize this again. We say attribute from ramp and yeah, so that's how we create some breakups in our density. Here's another one. A third one. We're going to take a look at these settings. We've got some animation on the offset here. None on this one. Yeah. And so if we take a look at all three of those together, we have this breakup. It's that one. It's this one. Cool. And then like before, we have a point velocity. So if we come down to point trails, we can see we now have some velocity on our points. Cool. And from there, we're just going to rasterize those attributes. And we're rasterizing the velocity and the density. These are our settings. We're going to cache that to disk. And then like before, we've got our collision geometry, which is our truck. And this time, we're going to take our fire simulation. We're going to remove everything but temperature and velocity. So we're deleting the flame field. we're clamping the temperature. So we've got a value between 0 and 1. We're resampling that. Here we can take a look at our temperature. And we're renaming the temperature to density. And we're saving that to disk. So this is we can take a look at our velocity, and that's going to go into our first context geometry. Our collision is going to go into the second geometry, and this source for the ground is going to go into our third. So let's dive inside and take a look at that. So diving inside the DOP network, we can see these are our inputs. This one comes from the second context geometry. This is the third, and this is the first. So the first one is our velocity from the fire. So let's take a look at that. So this is the velocity from the fire. We're reading in the density as density, reading in the density as temperature, and we're reading in the velocity, just a little bit of the velocity. So that fire coming off is going to emit density and temperature and velocity. As for the third, that is our ground. We've got density, temperature, and velocity. So just like the fire. So the ground and the fire together are both going to be emitting smoke, temperature, and velocity. But the ground has more velocity. You can see that there. Yeah, so just the ground is different. And then this is our collision. So collision and collision val, and that is of course our second context geometry, which is this one, the truck. And we of course have the usual suspects in a smoke simulation, the smoke object, our pyro solver, and a little bit of dissipation, a little bit of wind here, and we have these micro solvers here. These are simulation settings. And yeah, resizing. Cool. So up here we have a custom mask that's been created. And what we're doing is we're computing the gradient of the simulation. What the gradient is like the very outside surface. So like when you take geometry and you convert it to VDB and you use that SDF, that sign distance field, which creates the outer shell of the geometry. That outer shell is essentially the gradient of our smoke simulation. So we've got the gradient of our smoke, and what we're doing is we're going into this VOP and we're importing the velocity and we're importing the gradient and we're computing the dot product of those two. And what that means is that where the velocity and the outside edge of our smoke is aligned, we're going to keep that and create a mask, and we're going to export that as custom mask. And what that means is that, so let's say we have like an explosion in the center and it goes up, where it's going up, that velocity would be upward and the surface of it would be here. So we'd have like okay, so I'm just going to do a quick drawing here to explain a little bit better, and I will show this again in Houdini using points. So, but it's just easier for me to explain it this way. So here we have an explosion. Here we have the general velocity of this explosion. You know, it's sort of somewhat moving upward. And then we have this gradient. And when we compute the dot product of this gradient and these velocities, then we create a mask. And that mask is where the velocity and the gradient is in alignment. And that result should look something like this. And so if we have this mask And I've already, in this explosion, I've already got all the detail I want. But let's say you've got an initial explosion and you haven't applied your micro solvers to it yet. You would have these very like mushroomy shapes. Although, you know, sometimes the mushroom shape is what you want. Real explosions do have mushroom shapes, but if you have specifically big shapes that you want to break up with, say, a turbulence, well, you can create a custom mask like this and then apply turbulence just to these areas, and that will happen on the first frame, the second frame, and the detail will propagate throughout the simulation, and you have something very natural and realistic looking. So that is this custom mask, and like I said, keep watching the video. I will show this again with points, and I will show you the setup inside of the DOP network. So I hope that makes sense. Back to the video. So where the velocity and the outside surface is aligned, then we could isolate that part. We could also isolate the part where the velocity isn't aligned, but we could essentially use this map. So what I'm going to do is I'm going to go back to the beginning of this tutorial, and I'm going to record I'm going to build this from scratch, and I'm going to show you with points exactly how this mask is working. So make sure you watch the beginning of this tutorial, because I'll explain this bit. But essentially what it is the alignment of the velocity and the surface of the smoke. We can create masks there, and what that means is that we can then like create a custom mask, and then we can disturb just that part, and that can be quite powerful, because when you have an explosion going off, and let's say you don't have too much detail yet, and you get those mushroom shapes, well, we could just select just those mushroom parts, just the outside surface where it's billowing out, and then we can disturb just those areas, and that way we can break up that mushroom look and create something more natural looking. So that's essentially what this mask is doing. And if we come over to here, you can see this gas disturbance is reading in that custom mask. So that's the area that it's being controlled, and these are our settings for that. And the same thing goes for this turbulence. So this turbulence is not being applied to the entirety of our simulation. It's only being applied to specific areas on our simulation, and those areas, like I said before, are where the velocity and the outside surface are aligned. So that is our mask for that. Hope that makes sense. Like I said, go back to the beginning of this video and I'll create a better explanation, because I think it's something you need to see before it really sinks in. Then of course we have some gas wind and some gas vortex confinement, which, like I said before, just exaggerates the swirly motions and the turbulences that we already have in the sim. So cool, yeah. And then we have a ground plane as per normal, and that's it for the smoke simulation. And like we did before, we have a DOP.io just to import the density, velocity, temperature, and color. Although I would argue that all we really needed to cache for the smoke is just the density. And post-process, we could also resample the velocity, add that to disk, and put down a null out smoke. And here we have our pyrobake volumes, where we can just set our shader for our simulation. So the density of 2, this gray color, we're not going to use the scatter, we're not going to use the fire, it's literally just the density. Okay, and so here, I was explaining that gradient custom mask. Well, here we have some nodes that are going to visualize that mask exactly. So we're blasting everything but the density, and we're going to compute the gradient here. And then what we're going to do is we're going to scatter points in our volume like this. Let's maybe increase these have even more points. And then what we're going to do is we're going to use an attribute from volume, and we're going to copy that gradient information onto these points and the velocity. So now we have on these points the velocity and the gradient. So in this node here, you can see we're saving the gradient to the normals. And so this gradient information is now going to be referred to as n. And if we dive into this point VOP, we can now compute the dot product of our velocity and the n, which is our gradient. So it's not the normals, it's our gradient. And we just make sure we normalize because we need a value between 0 and 1. And then we can fit that between -1 and 1 because the result will be between -1 and 1. And so we fit range that, and then we feed this into this map and then out as color. And this is our map here. And you can see now, like I was saying, the very leading edge is red. And then we have this green color and blue. So let's remove this, set this to red and green in the center. And let's just isolate this a bit more. So you can see where the velocity is aligned with the surface, we've got this red color. The blue is whatever is traveling away from so in the opposite direction, and the green is in between. So a lot of the time when you create an explosion, what you want to do is isolate just the red parts, and then you could disturb or apply some turbulence to just these red parts, and that way you'll break up the mushroom look of your simulation. So that is essentially that's essentially the gradient. And that's it for our simulation side of things. Hope you learned something, and chat to you in a bit. Okay, so we're going to take a look at the rendering section now. So the first thing we want to do is we want to change this from build to Solaris, and change from the object view to the stage view, and make sure that we're looking through our render cam and we're looking through Karma. So I definitely recommend taking a look at our previous tutorials on Karma, but I'll quickly go over this setup here. So we're importing our ground with this SOP geometry, and we're just collecting the ground from here at the object view. So you can, you can just select this, copy it, Control C, go over to stage and paste that here. And that's going to import this. So we're doing the same thing for the environment. We're importing our cameras with an scene import cameras, our fire, and our smoke. And here we've got these rendered geometry, and we can just set some settings specifically for those objects. So these are our settings. Pretty straightforward. Same thing with the smoke. And here we have our lights. So we have a dome light. So this is just a solid color, and this is going to create this blue light that we see here. Then we have this light, which is the orange that we see up here, and this is set to sphere. So this is illuminating our fire area here. And then we have a distant light, which is like the sort of the moonlight. So these are our settings, and we have this tag ticked on so that we can we have this as an AOV. We're doing that for all our lights. Next we have this Karma fog box, and this is going to create a box that encompasses our scene for some environment fog. Again, a render setting, not visible to the shadows. And that's it for all our objects. Next, we need to put down a material library where we can work on all our shaders. So these are, you can ignore these are the shaders that we use. This is our soldier, it's just a basic diffuse. Nothing special here. Our environment is pretty much the same. And then we have these pyro shaders, which are created by the pyrobake node. So let's jump back to object view. And if we come to our pyrobakes, so like here's a pyrobake, and under quick setups, you can say create material. So like I said, I've done this before in this tutorial here, so go and watch this where I go over this a bit more in detail. And so let's jump back to stage, and I think these may have been tweaked a bit. So if you just go through here, you can see all our settings, and this is the fire one, this is the smoke one. So there shouldn't really be any use for this. As you can see, it's not changing anything, so that's fine. Next up, we've got this prune node, and we can just set this to our environment. So we need to select our objects here and drag them into here. So we're reading in the fire, the environment, the karma fog, and the smoke. And like I said before, you would select these things like this and then drag that up there. And that just ensures that we just render what we need. And I think in fact we should also prune the ground. Yeah. Well, this actually also prunes the ground, if I'm not mistaken. So if I move this, and enable this, yeah. So that's getting rid of the ground. And what Saber did, he did the render, is that he first rendered out the smoke, all of this without the soldier. So here are our settings for that render. And then in Nuke, he did some compositing on this, and he rendered out this scene. So let me just quickly head over. So something like this. This is the render. This is coming from here. So you just cache this out to disk. And then, do some glows, a little bit of grade, some vignette, some chromatic aberration, all the good old Nuke stuff. And it looks like this fire was added on top of the smoke. So we now have something like this. And then he rendered it out from here, loaded that in here, and isolated just the soldier here. And as you can see, we now have this red glow, and that is actually coming from that render loaded in as a texture here. So if we enable this, you can see we now have got some interaction with our soldier. Then we've just got an assigned material once again, and our settings for this. So we render out the scene, and then we render out the soldier, and then we just composite the two together. And that's about it. That's really it. If you want some more in-depth stuff on rendering Karma, like I said, check out our previous tutorials and you're good to go. Hope you guys learned something, and I'll see you next time.